Hello, good morning everyone. So today we are going to discuss about basics of signal and systems. In this, basically, we are going to discuss about the test series doubts. And gate doubts. Gate previous response doubts. So Ekeeda, let me first tell you about Ekeeda. Basically, it is a platform where you get various types of study material. Then we ask students to go through the study materials, lectures, and then we ask our students to be ready with the doubts. So Ekeeda is basically a platform where the you can subscribe to Ekeeda. You will get various benefits like the first benefit you will get that live doubt sessions, and the other is you will, if you subscribe to the channel, you will get notified whenever there is any new lecture or any new live doubt session is there, you will get. And other thing that you will get, that if you take a subscription, then you will get unlimited access for the Ekeeda lectures and various study materials and live doubt sessions. So now coming to the topic. We will discuss about, you can also use the, if you want to take subscription, then you can use the code GATE2222 to get a 10% discount. So now coming to the doubt session. The test series, this was the question. So in this, you have been given an input signal xt and impulse response st, and you are asked to calculate the output duration. So what this basically there is, you can do it by using the one is convolution, basic definition of convolution, and other thing is and the other thing is the shortcut trick, which is the starting of basically, let me do it here. This is xt is from 1 to 4 and st is from 0 to 2. Now, and st is from 0 to 2. So one thing is that yt trick, by trick what you can do, starting of yt is basically equals to starting of xt plus starting of ST. So YT will start starting of XT is from 1 plus 0, which is equal to 1, and ending similarly ending of YT is equal to ending of XT plus ending of HT. By this you can do this. XT is ending at 4 and ST is end. So duration of YT basically equals to is from 1 to 6. So the answer will be D. If you can check the solutions also. Other thing, the second method is using definition of convolution. This what you can do. This is basically how we calculate the convolution. So in this, there are 2-3 things we do. This is how YT is calculated. YT is equals to integration from minus infinity to infinity. X of tau and H of t minus tau. Just for a second. So this is how we used to calculate this YT. First we will draw X tau. X tau is same as XT, and then we will draw ST minus tau. For that, what we used to do, This is our S tau, and this is the main thing to how to calculate or final duration of the YT. So this is S tau and this is ST plus tau. And then we have done here shifting. This is left shifting by T, and then this is the time reversal. This is our X tau. From here, we can determine the convolution of the two. We can see that multiplication will be 0. Multiplication will be when multiplication will be 0. Multiplication will be 0. Multiplication will be equals to 0 when T is less than or equals to 1. Then there will be no intersection of these two graphs, so the multiplication will be 0 and the integration will be 0. Similarly, y equals to 0. Similarly, when T minus 2 is greater than 4, that means that T is greater than 6, yt will be again 0, because the curve will be like that. So this is 1 to 4, this is 1, this is 4, and when T minus 2 is here, T minus 2 is greater than 4, then in that case there will be no there will be intersection on time domain axis, so the multiplication will be 0, so yt will be 0. From here we can say that so we can say that yt will exist from t is equals to 1 to t is equals to 6. Now coming to the second problem. In this what we can do, if you have gone through the test series subject wise, then this is the second problem. There are two linear LTI systems are given. One is S1 and the another is S2. Both are cascaded, and we have to find out that what will be the overall order of the difference equation.
So this is very easy question. Suppose the first, this is second order system and this is also second order system. So the cascaded response will be fourth order system. This is also second order. Both are cascaded. So overall response will be fourth order. This you can determine using the definition also. Suppose this is HS1 suppose HS1 in, if we in discrete time system, this will be like that. Suppose AZ square plus BZ plus C in Z transform. And this is another that this is suppose A1, B1, C1. Then in that case, this will be A2 Z square B2Z plus C2. So the overall response will be fourth order. You can also see solution, and this is like they've considered the continuous time domain, and which is again same. So the order will be the same. So this is the solution. Now coming to the next. This is a very good question, theoretical as well as the from understanding point of view. So the zero state response of a linear constant parameter continuous time system can have components having the natural frequency of the system. The reason says that the force frequency components in the response of the state for any given input may not add up to the given zero initial value. Of the state, the natural frequency components may be needed to bridge the gap. So basically, this is the thing you study in the control system and signal end system and network system. Basically, there are 3-4 types of response. Natural response, and another is forced response. This is, you can also say, zero input response, zero response, and zero state response. And another thing we used to do in mathematics, that complementary solution plus particular solution. This we used to describe as YCT and this is YPT. So basically, suppose there is a system which is having equation like as square ys plus bs into ys plus c is equals to xs. This is basically input and this is the output. This is in Laplace transform domain, Laplace domain. To calculate the natural response, what we do is that we put initial conditions to 0. And to calculate the force response, we just put the state initial conditions to 0 and we give input access to the system. To calculate natural response, this is basically 0 input response. When the input to the system will be 0, but the system will respond according to its natural frequencies and what are the initial conditions. And this we used to do in mathematics, where we used to calculate complementary solution. And then for the particular input, we used to calculate particular solution. The overall response is always same whether you calculate by any of the method. So the overall response, let me say that overall response zero input response plus zero state response. In this input is equals to 0. And in this zero state response, matlab initial conditions are 0. Initial conditions equals to 0. Okay. This you can easily calculate from other thing, that y complementary solution plus y particular solution. Another is transient response plus steady state response. Steady state response. In every case, the overall response will be same. So what our question is saying that the zero state response of a linear continuous time system can have components having natural frequency. Definitely true. because when we solve for this zero input response, na, input is zero. But you can think of that equation again, that as square ys plus bs ys plus c is equals to xs. In this case, this will be zero. But still ys will be minus c upon as square plus bs. So there will be output that is known as natural response. Natural response or zero input response. This we can say that this is natural response. Natural response plus forced response. And when this input is not zero, then there will again will be response, which is known as forced response or zero state response. So this natural response can definitely have frequency components. Having natural frequencies. Similarly, the forced response can also have the natural frequency components. So this is the behavior of the system, any system. This is basically characteristic equation. So this will be in this you can see in the forced response also. So both are true, but it's not like that the output will be the force frequency components are directly added to the initial value. The force response is added to the natural response, not the directly to the initial condition. So that's why both are true, but this the region is not explaining the assertion. So the answer will be B. B will be the answer. Now coming to this. This you should know that what are the various types of response, how we used to calculate them. There is every type of solution is having their certain kinds of methods. That how to calculate the final solution. But the overall response will be same in either case. Next, coming to the fourth question, which is basically the impulse response of a system is given by this. Now, if two such systems are cascaded, the impulse response of the overall system. This is saying that This is one ST, and this is, and there is another ST. This is input, basically XT. This is output YT. So overall HT overall will be the convolution of these two. ST and ST. And this is basically impulse del T minus 0.5. Similarly, this del T minus 0.5. So the whenever any one is impulse, the convolution is very easy. The convolution is basically you put just this T minus 0.5 equals to this T. So this T is displaced by T minus 0.5. This T is displaced by this. Okay. This will remain same as it is. So the overall output will be both will be added. This is basically the property of the convolution. So the output will be, the answer will be C. Okay. Now let me clear all this and coming to the next. This is a property of convolution. They simply use that. This is the answer is C. Okay. Now coming to the next question. Simply we know that for the system to be stable, this must be absolutely summable. And it goes to minus infinite to plus infinite. This must be less than infinity. In continuous time domain, this is like integration of HT must be absolute in, matlab ST must be absolutely integrable. Okay, must be less than infinite. So this is our system for n greater than, so what we can say that an so the summation will be like a plus a square a cube and like that. So this is a geometric progression. And the HN will be, if we plot HN, so it will be like that. Suppose A is greater than 1, in that case, how it will be? This will be 1. Then this will be A. And this A square. This is A1 A square. For n is equals to 0, 1, 2, 3. This will keep on going. So this will not, the sum will not be less than infinite. So this is not right. And when A is less than, when A is less than, then the sum will converge, and the sum will converge, and it will be less than infinite. Simply you can also, that sum will be like 1 upon 1 minus A. Okay, from geometric progression of infinite, first term minus different whatever the ratio. So A must be less than 1, mod of A. Mod of A must be less than 1. And Bn is less than n is equals to 0. Impulse response is this. So for less than n is equals to 0, suppose if we plot the same. So in less than condition, what will be that? This Hn you can simply say An into Un plus Bn into U of minus n. When n is greater than 0, then you have to sum up this, and when n is less than 0, you have to sum up this. So now plotting B of n, U of minus n, U of minus n. This is basically n. Suppose, again taking the first case, B is greater than 1. So in that case, this will be what will be the first term? B inverse plus B of minus 2 plus B of minus 3. So that there will be reducing in amplitude. This is suppose this is suppose 1 upon B, then this will be again 1 upon B square, 1 upon B cube, for minus 1, for minus 2, then minus 3. So the sum will converge. Sum will converge. It will be less than infinite. So this is true. And the first, and in the last we have seen that the what was another was that a must be less than 1. Okay. Why we are taking modulus? Because our condition said that the absolute response must be absolutely summable. To be stable, that's why we are taking modulus. Now coming to the next. This is the solution. You can see that the system to be stable, this must be absolutely summable. For sum to be finite, that this must be less than 0, this must be less than 1, and this must be greater than 1. Now coming to the next question. This is very standard. That whenever there are two pulses are there, let me give some kind. Suppose this is one rectangular pulse. Okay. Starting from suppose A to B. Having amplitude A1. And another is from C to D. Okay. Having amplitude A2. So the convolution of these two will be this pulse. It will start from A plus C. Okay. It will go like this. This will come like this. Duration of this is T1 is equals to B minus A. Duration of this T2 D minus C. So this will start from A plus C. Okay. And there is one assumption that suppose I am considering that T1 is less than. So this will be the equals to this will be equal to smaller duration. Smaller duration के बराबर होगा. So if we add this duration B minus A, so this point will be B plus C. B plus C. Like this end point, ending of the final convolution will be equals to ending of these two. This will be B plus D. Now again we have to subtract the smaller duration. This is the smaller duration, na? This smaller duration we have to subtract from this. So I will subtract minus b plus a minus b plus a. So this will be a plus d. And this amplitude will be a1 a2 into a smaller duration multiplied by a smaller duration. Okay. So whenever there is unequal duration, then it will be trapezoid. And when the duration is equal, in that case, it will be a triangular shape because this will come here and this will come here. Because D will be like, suppose D is B and this is also A. So put C is equals to A and D is equals to B. In that case, what will happen? That this will be equals to A plus B. This will be 2A. Let me write in another different color. This will be 2A and this will be B plus A and this will be A plus B and this will be 2B. So these two will be same. So these two will be same na. So it will be a triangular. So in our case, since the rectangular duration T1 T2 are different, so this will be when T1 is not equals to T2, and this will be triangular shape when T1 is equals to T2. Okay. This is equals to this. Now coming to the next. This is the solution convolution of two different durations. Rectangular waveform is trapezoidal. And if durations are same, then it will be a triangular. Now the next question is that unit impulse response is given. And we have to calculate the input is also given and we have to calculate the output. So this we have to take. So the convolution in the discrete is given by, suppose this is xn and this is hn. This is hn. Xn is over 1 by 2 1 by 2, 1 by 4, 0. You can leave it here whenever 0 is there in last, because other terms will be 0. You can just write if you want. And this is 1, 0, 1. After last 0, you can extend to the time up to which you want. But all the terms will be 0. So 1 will be 1, 0, 1. These will be 0, 0. This will be 1 by 2, 0, and again 1 by 2. This will be 1 by 4, 0, and 1 by 4. These all will be 0. So you can simply omit these things. You need not to write these zeros. Last non-zero, you just like last non-zero. You can simply omit these things. Okay. So now the first will be this. Second will be this. The third will be some of these. This will be the fourth. And this will be the fifth one. Okay. But you can simply omit these zeros because they are not going to add. So just stop here whenever there is non-zero. Last non-zero term, just write last non-zero term. Last non-zero term. Similarly here. Okay. So our output will be 1, 1 by 2, 1 by 2. This will sums to 5 by 4. And sum of this will be again 1 by 2. This will be 1 by 4. So which option is correct? D is correct. D is correct. Now let me clear this and come into the next. The solution you can see if you want. This is basically a definition of convolution. They've directly asked. What they have asked, that input output relationship. So this is a system Hn, this is output Yn, this is input Xn. We know that Yn is equals to xn convolution hn and the summation form definition of this is that xk into h of n minus k is equals to minus infinity to plus infinity. Thus, in second form, you can write it x of n minus k hk. So they directly ask this formulas. What you have to put? You just have to put xn is equals to an into un and hn is equals to b raised to the power n into un. So which will be the answer? Using this one or this one? A is correct using this one. This says that using this formula. And another option, you can check A and UK not correct. Not correct. This is also not correct. So A is the right answer. Sometimes there are multiple choice questions also. I mean that multiple answers are correct. Single answer correct, single choice, multiple answer correct. Now coming to the next question. This is the right answer A. This is consider a discrete time accumulator system. Yn equals to summation of xk from k is equals to minus infinity to n and the another is backward difference system. Where the yn will be xn minus 1. X dot represent input and this y dot represents output. So this is basically accumulator defined by this equation, and this is another is backward difference system defined by this equation. When these two are cascaded, we have to find the overall impulse response. So impulse response H1n. How to find impulse response? We just have to give the impulse as the input. We will give xn equals to del n. In this case, yn will be equals to h of n, impulse response. So h1n will be k equals to minus infinite to n del k. If we sum impulses from minus infinite to n, it will simply become u of n. Okay. What will be the h2? And for this, h2n will be, you just put input as impulse, then you will get this impulse response. The response will be equal to impulse. So this will be del n minus del n minus 1. So this impulse response is un, and this is del n minus del n minus 1. Now you have to convolve these two. And determine the overall response. Convolve these two. So let's do that. You can see it here. The first, this is un and this is del n, and there convolution. Convolution of impulse with any other signal is same as that signal. You just have to put that domain in that signal. That is, suppose this is basically convolution property. Xn convol del of n plus alpha will be equals to xn plus alpha. This n is replaced by this n plus alpha. And the function nature will be same, the signal nature will be same. So convolution of this with this results into UN. And this with that is results into this. So H1n is equals to del n. How? Because this is UN. If we plot now, this is very crucial step from here to here. UN minus U of n minus 1 is equals to del n. This is over UN and it continues infinite. Okay. This is n. And what is U of n minus 1? Just shift right by one duration. Okay. So this will be one here, one here, one here, and then it will be continue. So this minus this will result in impulse at n is equals to 0. That's why we have written del of n. Because only this will be left. When we subtract now, this will be left. All other will get subtracted and this will be left. Now coming to the next. This will use some other knowledge also, like Fourier transform, and this is ideal low pass filter. Say this is h of omega minus omega naught to omega naught. This is omega. So when we do inverse Fourier transform, what we get is a sinc function. Is a sinc function. Like this we will get. Okay. So since HT ST is not equals to 0 for T less than 0. So this is non-causal system. This is not physically realizable because it is non-causal. का मतलब ये होता है नॉट फिजिकली रिलायजेबल। नॉट फिजिकली रिलायजेबल। ओके, so this is not causal and this is not physically realizable. So answer will be never physically realizable. Now coming to the other additional doubts. If you have any doubt, you can ask regarding previous year GATE questions. Otherwise, I will discuss some good questions from previous year GATE exam. Coming to the next. The answer you can visit if you want to visit. We will also discuss these. First we will discuss the questions from the test. Then we will discuss the previous year GATE questions. So let me tell you very important things. Okay. This was our first. Let me close it. This is our second. Now coming to this, what I will like to tell you. What are some basic definitions? So they have given input output relationship and they are just asking whether which one of the following is causal system. Okay. So for causal, I will just tell you two definitions. They will be always applicable. First is output YT must depend on present input or and or both, मतलब and or past input. In other words, you can say that should never depend on future. Output must not depends on future values of input. Must not depend on future values of input. Future values of input. Okay. The another definition is that HT must be 0 for t less than 0. From these two definitions, you can tell whether the system will be causal or not causal. So since we are given with input output relationship, we will use this definition. First definition, you can see that input is xt and output is yt. So here you can see that yt is depending on future. Suppose I want to know value of y2. So it will depend on the value of x6. Y0 will depend on x4. Y2 will depend on xc. So it's, you know that the value at any state of type depends on the future value of time. So this is not causal. Again, this is not causal because it depends on the future value of input. And this is again not causal. So this is the only system which is causal. You can use second method also to determine the solution. For that, you have to first determine HT. So to determine HT, what you can use, that you just put input equals to del t. T plus 4 into del of t minus 1. So on solving, you will get 5 into del of t minus. So on plot, you will see that this will exist. This is time, and this is del of t minus 1 into 5. So it will exist here at t is equals to minus 1, having amplitude of 5. Sorry, it will exist here in right hand side because t minus 1 right shift will be there. So let me say that it will exist here. Let me take a different color. Here there will be impulse at t equals to 1. So now you can say that st is 0 for t less than 0. So the system will be causal. So using method 2 also you can determine that this system is causal. Now coming to the next. This you can determine causal. This is input output relationships are given as below. These are input output relationship. They just want to know whether this is linear and time variant. Again, I would like to tell you definition of linear and time invariant. Linear system will follow two things. One is superposition. Another is homogeneity. Okay. And another definition, this is the first definition of linearity, and the second definition is having two conditions, that initial conditions must be 0 and there should not be any non-linear operation. Either on X domain, either on input domain, that either on XT is input and on YT output. Using these two definitions, you can always determine whether a system is linear or not linear. So from this definition, since the initial condition, they have not mentioned any initial conditions. So initial condition is 0 and this operation is linear. So the system will be linear and we have to check for time invariance. and we have to check for time invariant. Again, for time invariance, there again are two definitions. Or you can see two methods. First is that suppose you give input xt, then output is yt na. Then in the case of input xt minus t naught, this output should be yt minus t naught. Okay. The other definition is theoretical, kind of, it's a short trick. It's a kind of short trick. What that definition says, all the coefficient all the coefficient used in system relationship must be independent of time and there must not be any time scaling. So using these two definitions, you can just tell whether the system will be time invariant or time variant, linear or non-linear. So coming to our question, we can say this is the solution. They have checked first for time invariance. They have given suppose input. Suppose let me just using this method 2, you can simply say that there is no nonlinear operation. Let me solve it here. Method 2 means what I have written theoretically. That theoretical definition, no nonlinear of operation, no nonlinear operation. No nonlinear operation. And what was the other? Initial conditions 0 initial condition. So this will be linear. Okay. So from these two say you can say linear. Okay. Similarly for that time invariance, That coefficients are time independent. That system relationship coefficient are time independent. Are time independent. Another was that there is no scaling in time domain. There is no scaling in time domain. Okay. So it is time invariant. So you can say from these two. Time invariant. Okay. Now coming to the classical method, mathematical method. That for linear t, suppose output y1 t when input is t minus t when input is x1 t. So in that case, it will be x1 u and output y2 t when input is x2 t. Okay. In this case, input was x1 t, x1 t. In this case, input was x2 t. This is input basically. Okay. Don't take it this. So when I am giving input, x1 t plus x2 t. In that case, output yt will be integration from t minus t to t x1 u plus x2 u du, which is simply equals to y1 t plus y2 t. Suppose I am giving input ax1 t. In that case, output yt equals to t minus t integration to t up to t ax1 u into tu, which will be a being a constant, will come out of integration. So this will be again x1 u into du, so which will be a y1 t. So this is superposition. So this is the superposition. And this is homogeneity. So the system will be linear. Okay. Similarly, we will go for the time invariancy method one. The method one, which is mathematical, or you can say by definition. You can say by definition. Okay. So what the mathematical say definition says that when input xt is there, then output is yt, na? So xt minus t naught, output must be yt minus t naught. Okay. Yt minus t naught. So suppose I'm giving input. Now xt output, we already know yt, xt minus t naught. In that case output. Suppose I say y shifted t. Suppose this is y shifted t. This must be equals to shifted version of it. So in that case, t minus t is t this will be x of u minus t naught du. This is the input, so this will be the output. According this input, simply t is replaced by u. Now coming again to that, suppose I assume that u minus t naught is equals to v. Okay, so du will be dv, and v will vary from when this you put u is to t minus t, so d will vary simply t minus t to minus t naught. Okay, so the integration now becomes t minus t naught, t minus t naught, and xv dv. You can see that if you replace t minus t naught in y, in this yt, then also you will get same. So this yt was if you go by definition, yt was t minus t to t xu du. Okay, simply replace this t minus t naught here. In that case, you will get, suppose I am replace here in this relationship. In that case, I will get simply I am replacing t with t minus t naught. Okay, just replace this t by t minus t naught everywhere. Minus t naught. So I will put t minus t naught here. I will put t minus t naught here. My relationship will become. See, these two relationships are same. See this limit, they are same. and see this limit and this limit and this function integration. So we can say when I'm shifting the input by t minus t naught, my output is also getting shifted by t minus t naught. So the system will be time invariant. Time invariant. Now coming to the next. This you can check for the solution. This is the next. This definition I already just told you. We have to find out that the system is linear or not. So by linearity, using the definition, that system relationship must not have any non-linear operation and all the initial conditions must be zero. Non-linear operation नहीं होना चाहिए. ये नहीं होना चाहिए. No non-linear operation and initial conditions zero. Then system will be linear. So there is no non-linear operation on y and on input u. Non-linear operation means that there should not be any square. There should not be any square or any power, trigonometry functions, logarithmic functions, exponential functions, logarithmic. They must not operate on x or y, etc. Any non-linear x or y or both. So we see that there is no non-linear operation on y and there is no non-linear operation on u. And initial conditions are given zero, initial rest conditions. So this system is linear. Here again, you can check that this is our input, this is our output. So there is no non-linear operation on this and this. So this is again linear. Since integration and differentiation, this operator is linear, you know, integration and operators are always, differential operators are always linear. This is not linear because initial conditions are not zero. So this is not linear. This is the our answer. They have asked which is non-linear. And this is again linear. Y is equals to mx type of relationship. Now coming to the next. The system relationship is given. Yes, system relationship equation is given. So first we will check for linear or not linear. So there is non-linear operation here on YT. Here also you can see that there is a square of YT, square of XT. So they are non-linear operation. No? This is non-linear operation. This is non-linear operation. This is non-linear. So function will be non-linear. Okay. So system is non-linear. Now we have to check whether it's dynamic or static. Again, there is only two definition for static and dynamic. You can see that for static, one definition is that output depends on present input only. Present input. इसका मतलब है कि ना तो पास्ट इनपुट पे डिपेंड करेगा और ना ही फ्यूचर इनपुट पे डिपेंड करेगा. Output will neither depend on past input nor it will depend on future input. दूसरी डेफिनेशन कहती है that HT must be K del T. यदि आपको सिस्टम रिलेशनशिप दी गई है तो आपको इस डेफिनेशन का यूज करना है और यदि आपको and if you are given with system response then you have to use this. So we will use this definition, first definition, because system relationship is given. So here output is not depending on any past or future value of input. So the system is static, जिसको हम कह सकते हैं, which we can call non-dynamic. Non-dynamic. Okay. And linear and non-linear definition, I've already told that this is non-linear operation, this is non-linear, and this is non-linear. So the system will be non-linear and non-dynamic. Non-linear and non-dynamic. So the answer will be D. Now coming to the next. Time invariant. Again, we can use the definition I have provided. That all the coefficient all coefficient must be independent of time. Independent of time. And another was there is no scaling on time domain. No scaling on time. So here this coefficient is depends on time. So it will be time variant, time and variant, before variant, before. Here there is a scaling on this time domain, this -1. So it will again time variant. And here this is again the coefficient depends on time. So this will be time variant. So this is the correct answer. That there is no coefficient which depends on time, and there is no scaling, and there is no scaling on time domain. So this will be the time invariant. Time invariant. Okay. So B will be the answer. You can also use method 2 to calculate. Now coming to the next question. This is the basically method 2, which you just put x1 and then you will shift n by n. That xn output is yn. Then what you will do, xn minus n naught, output is yn minus n naught. This is basically method 2. You can solve using method 2 also. Then also you will get the same answer. Same again, you can use that definition of causal or not causal I have provided already to you. This is non-linear because of this 2. This is not non-linear. Again, this is non-linear. And this is using the input depends on present, output depends on present input only. So this is casual, and here for this you can say that y of -2 depends on x of 4. Write it clearly. So this is basically that inputs depends on future, so non-causal. Non-causal. So now you can say that A will corresponds to, this is causal, linear and causal and linear. So linear and causal matlab means 3. B will be again linear and non-causal, since this is NC. So linear and non-causal, this will be 2. Why this is linear? Because there is no non-linear operation on y and x. and this is, I already told you, non-linear. So there is scaling in time. So this will be, but we have not to check for that time invariant. Na? This is time invariant. Extra question if you want to. So this will be, again you can say that this will be non-causal also, non-linear and non-causal. So this will be 1. Because in this case, suppose if you want to know y of -1, then it will depend on x square of 1. It's depending on future value. Okay. So this will be non-causal and non-linear. So 1, this will correspond to this. This is non-linear already, and this is causal. It depends on causal system. Okay. Now coming to the next. This is, we have already done the similar question. This is ditto same. If b is equals to 0, then the system will be linear, because we have already told that initial condition must be 0 for a system to be linear. What you can say in another words, when that xt is 0, output must be 0. When xt is equals to 0, then output yt must be 0 for a linear system. Then output must be 0 for linear system. So it will be linear for any value of b. No, it's wrong. It's wrong, and it's always non-linear. Okay, so this is the correct answer. Now coming to the next. This we will do using, you can, I will do just 2 methods. Method 1, which is the statement method, or you can say theoretical method, statement method. Or theoretical definition. So for system to be, let's first check for causal. Causal के लिए क्या था कि input must not depends on future value पे depend नहीं करना चाहिए. Input must not depends on future. So let's first check that. Suppose I'm checking for y of -2, then it will depend on x of 4. So it will be non-causal. Okay. So it will be non-causal. Answer will be non-causal. You can directly also say that there is a scaling kind of, there is a operation on time domain. Na? So in this, so there is non-causal. Okay. And now coming to linearity. Linearity. For linearity, what we will do, again by definition, that coefficients must be independent of time. Coefficient must be independent of time and zero initial condition. Coefficient independent of time, independent of time and zero initial condition. And zero initial condition. Okay. So when input is zero, output is zero, so linear, and there is no nonlinear operation on y and there is no nonlinear operation on x. So the system will be linear. This will be non-causal and linear and time variant. Why time variant? Because there is time scaling in this time domain, na? So this will be time variant. So you can add that the system will be linear also. Non-causal from here because it depends on future value, and linear, there is linear relationship. And time variant because there is scaling in time. You can use method 2 also, that when I am giving input xt minus t naught, in that case output is main output is yt, which will be x of t square minus t naught, which is not equals to x of t minus t naught. T minus t naught square. Okay. This is not equals to this now. So this is time variant. So time variant. So rest we will do in next class. There are 2 questions remaining from test and previous year get questions. Okay. You can go for questions if you want to go. They are again very easy. Input output relationship, you can go by definition. And this is the definition of accumulator. So inverse system is differentiation, difference equation. So see you in the next doubt session.